Good morning from sunny Texas. Good afternoon in Maced. No, not in Macedonia. In London, you're talking to us from. You're originally from Macedonia. That's what I'm mixing it up. Bojan Jakimovski works with Loka and has lots of AI experience, and that's why we wanted to talk to him this morning. Bojan, please go ahead and introduce yourself and tell my audience what you do and how it is that we were talking to you this morning.
Hey, thanks, man. First, thanks for the invite to talk on really interesting subjects today. So, I'm Bojan Jakimovski, senior machine learning engineer in Loka. Uh, Working in the popular AI field, but mostly I'm working with generative AI and MLOps solutions. I'm a guy that wants to mix low level with high level, with infrastructure, all of this fancy stuff. But something that is really interesting for me and I'm actively researching is synthetic data generation. I started to experiment with synthetic data generation during my master thesis. By the way, I have a master degree in dedicated computer system, experimenting with small language models, to be precise, retrieval augmented generation with small language models. And at that point, when I was doing the research with small language models and RAG, I came to the subject of synthetic data generation. And yeah, here we are, actively researching into that.
Awesome. Yeah. Synthetic data is something that comes up nowadays in the localization all the time. Also, probably because we have an alternative to synthetic data as well. We have been accumulating translation memories with real data for a long time. That might be handy to the industry, so to speak. But let's talk a little bit about synthetic data for multilingual AI. How do you think synthetic data enhances multilingual AI models, and particularly the low resource languages that you were talking about?
Exactly. Awesome question. So I think here can say my story of how I pinpoint synthetic data, especially with multilingual AI. As you said during my introduction, I'm from Macedonia, and not a lot of large language models can handle easily Macedonian. So my first thought was, hey, how can I create an LLM or a small language model, SML, that can handle Macedonian, right? So I wanted to do some post-training fine-tuning of model on Macedonian. And my first thought was, so for any good AI model, you need data, right? How to collect the data. I was extremely lazy to do it manually and to translate it and to do all this fancy stuff. And I thought to myself, okay, so maybe some of the larger models can easily handle, not easily, but can handle at some degree Macedonian language. Can I use them to create artificial data set, synthetic data set by utilizing them? And that's how I figured out that synthetic data from other LLMs can be used to create that data, so we can let's say diversify AI models to be able to handle multi languages. When I discovered this, it was like eureka moment for me, because I figured out that we can have AI models on multi languages that are not frequently used, or the population that speaks is not large, and then this approach showcased me that previously AI systems that were limited by authentic data now are basically unlimited, so we can develop something interesting.
Yeah. What are the challenges in generating synthetic data that accurately reflects the linguistic nuances? Because it's one thing to spit out a set of data that is maybe a Macedonian, but I assume that that data is not completely clean when you start doing it.
Oof, yeah. you hit the right one on this question. Yeah, it was not a straightforward process, to be honest. It was not straightforward process because generating synthetic data, mainly with generating synthetic data, mainly you have three challenges, right? One of that, for me, what I personally classify is realism. So how the synthetic data actually captures the complexity and variability of a natural language, of a particular natural language, in my case Macedonian, was not a straightforward process. Mainly, that's because of the background of the language. So it depends from case to case. For example, if you are using LLM to generate the synthetic data, I don't know, on Chinese, because most of the LLMs have in fact are trained on large data on Chinese, they can better capture the realism of that language compared to Macedonian. That was a big pain point for me. The second challenge was the bias. So you must take into consideration the bias that the LLM can create when you're using the LLM to generate synthetic data. Also, what was really interesting for me was something that I call as cultural context. So how the LLM can basically capture that cultural context that came from that is a part of each language. So I don't know, if you use LLM to generate synthetic data on English, the cultural context can be easily captured and easily interpreted. But for Macedonian, you do not have, I don't know, all the slangs that we have in daily conversation, in real life, or even in some literature that is not like used on daily basis. And those were the three main challenges, the main points that were really difficult to handle. So yeah, in those cases, you need to sit down again and manually filter all the data. But it's much more simple compared to doing the whole translation and then finding the correct data sources from the get-go.
Yeah, and we touched upon this already briefly at the beginning of the conversation. I think there might be an opportunity for organizations like yours to work together with LSPs, language service providers, that have accumulated bilingual translation memories in rare languages, and that way you could have very clean data and a data set that you wouldn't have to incorporate and test, so to speak. Do you think this is something that we have been talking internally in the localization industry for a while as well? Do you think that synthetic data sets, or data sets of translation memory for that matter, can help in preserving endangered language through AI models?
Oh yeah, for sure. But to capture this, let's say, not to capture, to preserve these languages that are not used these days, especially small languages like of societies where they when the speaker of those languages are the number of speakers of those languages are really small. You must have some real data, right? The real data must be the ground truth, as we say here in the AI industry, and that real data can be enriched with the synthetic data to keep, let's say, dying languages, to keep dying languages in life cycle, so to be alive. We Besides these discussions, we had a really good discussion previously with you about I don't know, languages from small societies in Australia or in Africa, where the speaker of particular language, the numbers of the speaker in particular language are really small and they are dying. So I see a lot of use cases of synthetic data, or not just synthetic data, or AI in general, to be used to preserve these languages and to keep basically their existence happening in near future. Yeah, this is a really good topic that we've pinpointed on this one.
Yeah.
I mean, the AI can do miracles for
Yeah.
keeping dying languages alive.
And when you're creating this kind of synthetic data, how does that explain to us a little bit how that really works? Are there any ethical considerations that you have to apply in advance? Are there things that you're paying attention to? Like you're sitting in front of your LLM and you're getting ready to create synthetic data. I'd love to get a better idea of what it is that you'll be doing and how what the cleaning process looks like, etc.
Okay, so to make my life much easier for creating synthetic data, I sit down and said, "Oh, maybe I would need to write a Python package to automatization to do some automatization for this stuff." And I did one. It's called SynthGenAI. It's not a perfect solution. It's mostly for personal use case, but I've seen some traction on the small language model and synthetic data generation community in the world, and I have, I think, 40 or 50 GitHub stars. So it's a good start. And how the whole process looks. I sit down and first I basically define multiple things. The first one is the language on which the synthetic data will be generated. So that's one of the parameters I'm entering into my Python library. So the first one is the language. The second one is the topic. So for example, if I want a synthetic data generation of data that is, I don't know, near for healthcare industry or for finance or social media posts on a particular language, etc., etc. I'm writing that down. I'm also giving an additional description to the system to basically, which at the end of the day, it's simple system prompting in the background to say to the system, to the LLM, how to what will be the behavior of the LLM. For example, if I want a social media post synthetic data to be more like for Gen Z or for specific target population, I'm basically navigating the LLM to create that data. And the first thing I'm doing is to create keywords. So for how many entries I want, for example, 1,000 entries into the data set, I'm saying, hey, for this specification, create me 1,000 keywords. And each of that keyword with the combination of the other parameters, so the description, the language, the topic, is used to create an entry to the dataset. Why I did that route is basically because I wanted to make it randomized and to make it, let's say, deterministic. When you, for example, want to create the same data set with all of the same entries, you can create it, because the LLMs are known to have problems with the deterministic approach. That was my first go-to. And the second point was, when I was creating those data sets, I wanted to know at least how the LLM was thinking when when they were created. So I can sit down, especially if I have a data set, I don't know, in health, for healthcare industries or for health documentation, to sit down and to see, oh, maybe here I have bias. Maybe the LLM started for this entry to hallucinate. Drop this entry. This is not a good entry, etc., etc. So I wanted to make the whole process really traceable, so I can capture like how the LLM was thinking when it was creating that data set.
Yeah, it's really interesting. I've never really heard it described like that. So, as the LLM is generating the data, are you sitting there and checking the data as it being created, or you're letting it accumulate, and then somebody, or you have another program run through the data to check for hallucinations and that kind of thing? Is it an automated process? Or is it Bojan sitting in front of the computer and scrolling through the text, so to speak?
I would consider this as semi-automated process.
Yeah.
Because how I'm doing, I run the data pipeline to create basically the synthetic data for, I don't know, 1,000, 2,000, 10,000 entries, which are basically paragraphs of a particular text. And I continue to do rest of my day, like my other activities at the end of the day, or I'm like opening my server to check how the pipeline is going, and like basically the accumulation of data entries into the data set. And after that, I have two choices. So that's why I said semi-automated. If I want to go fully automated, I have some other, let's say, Python frameworks that are used to test the toxicity, the hallucination of the LLM for particular context and for particular input, like Ragas, DeepEval, etc., etc. And that's the automated, if I want to go fully automated route. But usually I'm going with the semi-automated route. I sit down, open the data set, and basically skim it through it row by row, entry by entry, to see if it's good or if it's not good. For example, my library has a really good integration with Hugging Face datasets. So after the dataset is created, it automatically goes to Hugging Face datasets, and there I can sit down and basically scroll with my mouse. Hey, this is good. This is good. This is not. Drop this row and continue through the process. Because I choose the semi-automated route because I have more, let's say, I trust it more compared to the fully automated route.
Yeah. So now you have a data set, you've cleaned it, you're kind of happy with where you ended up. Give us an idea of what that data is being used for in general, so people that are not familiar with what's going on in AI in that sense can get an idea of what you're using the data for and how it's most useful.
Nice. So what I did with my library was basically try to create different types of data sets. So basically, you can say to the data set, to the synthetic data generation pipeline, oh, I want a conversational data set. And those conversational data sets are mostly useful for fine-tuning LLMs when we want to have an LLM which is more human-like.
Yeah.
To basically what we are doing on daily basis with ChatGPT. When we talked with ChatGPT, I think you also talk. Probably you're also talking with ChatGPT like a human
I've
being.
never talked to ChatGPT. I wouldn't do that. No, seriously. Of course I do. I wouldn't be talking to you probably if I wasn't involved in that as well. And you know, a lot of the linguistics, the things that really attract me to interacting with large language models is seeing how I can be more effective with them. And it really does have, you know, some human aspect to it in the sense that you interact with the large language model and you find out pretty much like when you're developing a relationship with a person, what works best to have the large language model interact with you and give you the best results, so to speak. And it's funny how human like that feels, wouldn't you say? If you're giving the LLM a compliment and thank the LLM for a prior entry, then you can see it behave in a similar way going forward. So I'm sure that that's the kind of thing probably that the LLM is learning from human interactions. How when people are happy and compliment each other, uh, they it's an encouragement, or it's seen as an encouragement. So those are very human traits. Am I getting that right? Is that kind of how it works?
Totally. And basically, why today's LLMs work on that way is mostly because of synthetic data. So there's even the big frontier labs like OpenAI, Anthropic, or I don't know, if you go for Hugging Face, they created a really good small LLM model family of models. Besides the real data, which is basically scrapped from the internet, right? They incorporate synthetic data with conversational manner. So, and they say to an LLM, hey, create synthetic data that is like, that has the form of conversational between two humans. And that's why now the LLMs are much more, let's say, conversational looking, which for some folks, they do not like it. But for me and you, it's really awesome. And that's one of the use cases. The rest of the use cases of synthetic data generation that can be done, for example, with SynGen AI, are the classical NLP approaches. So you can create a synthetic data generation for text classification, for sentiment analysis. If you, I don't know, get a sentence to say this sentence has a positive sentiment, neutral, negative sentiment, basically, or a translation data set. You can pinpoint, hey, create me data entries, 1,000 data entry points of, I don't know, text that is English translated to Macedonian, Macedonian translated to Serbian, or Serbian translated to Greek, etc., etc. That's, I think that's the beauty of the LLMs. They can, with good tuning, with good navigating in this embedding space of the LLM, you can make the LLM to do whatever you want.
And it must be beneficial that you speak multiple languages there too, to be able to understand the nuances between the different cultures and then the different languages. Wouldn't you agree?
Yeah, for sure. And in fact, that's the bias moment we've talked previously. If you do the same, let's say, the same input for the LLM to create basically the same topic, the same description, everything will be the same besides the language. So if you say, oh, create this type of data set for English, for Macedonian, for Serbian, and for Spanish, you will see that there's some bias in each of the data sets. And that mostly comes from the data that is incorporated previously into the LLM, into the already embedded data in the LLM. And it's really beneficial when you are when you know multiple languages, to basically capture that bias from a human point, from a personal perspective point, to see, oh yeah, really LLMs are biased.
Let's talk a minute about multimodality and the fact that nowadays working with LLMs means not just working with text, it means working with audio and visual content. How does that affect your day to day? How do you prepare for that?
Oh, yeah. Besides the agent topic that is a hot topic these days, you've hit the second hot topic, which is multimodality, and those two are really well connected. So as you said previously, I mean, the past 2 years after the whole Gen AI boom, we were really frequently working with text, and I think we hit to a particular point when text was not enough. Was not enough, right? Now you can see more and more multimodal models, which means a model that can easily handle or capture context between text, audio, images, videos. And if we want to analyze the multimodality models more from linguistic perspective, what that means. Previously, we were capturing only text, so we can see the context of the whole sentence or a conversation only through text. But now, with models that can capture context with audio, for example, we can capture the tone, we can process the sarcasm, the emotions, basically whatever each of us is talking, right? And I think that's the beauty of the multimodality models. We can basically be fully human. We can say whatever we want to the system, and the system is now able to capture the whole information as a one whole, as a one. Previously, we needed to use multiple models for text, for speech, for videos, but now everything is like plug and play, and it's much easier to be handled. And with these multimodal models, I think we've opened the Pandora box. We've opened the Pandora box for multiple use cases. So imagine you can now have one multimodal model which can handle voice, speech, text, video, images, and you can make that model really personal. You can add the personification to the model much more easily, and those models can basically be really good for each of us. You can have one multimodal model that is, let's say, personalized for your use cases. I can have another, etc., etc. So yeah, this is a really hot topic these days, but let's see what will happen in the next couple of 6 months to 1 year. We will see a lot of use cases that currently at this point we do not think about it. Believe
Okay.
me, I think that this will be a big one.
And you're mostly working on text, or you're working with audio visual and different modalities as well?
These days, I would say text and images mostly. And images more in the frame of working with documents that can have multiple tables, can have multiple paragraphs of text, multiple images of graphs, and now these multimodal models can easily capture the context of those documents, and we can use those models to basically do any kind of insights we want on that data. So yeah, as we said, the Pandora box is open.
Yeah. So when you have a graph and the graph is showing, I don't know, sales numbers or temperatures or whatever data it is, the large language model can now analyze the content and actually say something about it like a human would, as far as the content is concerned. Am I extrapolating that correctly?
Yeah, this is basically true. So a really good example, and that's mostly the biggest use case currently. So you have, I don't know, some finance data, some finance document with, I don't know, graphs of how the sales were increasing or during a year. And previously, you would need a human to sit down and basically do the analysis. I don't know, in Python with pandas, do some statistics. Now you can basically put all of the data to the VLM, so to a visual LM, and you can say, hey, please analyze this document and give me some insights of how the sales were for, I don't know, for the first quarter of 2025. And it will analyze the data, and it will give you some insights that can be helpful in matter of, I don't know, seconds, not just minutes, seconds. Previously
Yeah.
would need to sit down and to do the task manually. Like it will basically be for hours, like for full working day, 8 hours. Now you have that in matter of seconds. That's
Yeah.
the power of these models.
So one of the things that I'm noticing is that in lots of industries, there's a lot of interest in implementing artificial intelligence, but there's also some paralysis going on at the same time because there's a lot of pressure to do it right and not make a mistake. And it's my impression that in the localization industry in which I work, there's quite a bit of that going on, in the sense that people are worried that they're going to make a mistake. And what best practices can you think of as an AI guy, as far as the framework is concerned, to implement AI workflows in a more streamlined way?
Oof. So yeah, as you said, from one side we have let's say the push to implement AI. Everyone wants AI, how we can automate, but on the other side there was like, hey guys, stop make a break. This could be dangerous. We can get lost by ourselves to implement these AI automatization tools or data processing tools. And now the question is, okay, how we can put down some pillars that will help us. I mean, not. I'm talking here more from enterprise point of view, from for big companies that have a really big frameworks of implementation, new software or new solutions. The mostly important from my perspective and from what I've seen in the last couple of years is the data management guidelines. So if you keep your data private, secure, safe, if you give the correct data to the models, to the AI models, it can be a pure statistical model like the old school classical ML, or even the latest models like the LLMs, you are in a good situation. You are in a good place. So data governance is the first one. The second one, so that's the first pillar you must take into consideration when you are building a framework for implementation of AI. The second one is the evaluation. So yeah, you can have a fancy schmancy AI system implemented with the latest state-of-the-art solution, but does it basically do the job that it needs to do? So you need to evaluate the whole system. So evaluation is the second benchmark. And here it depends from use case to use case, how the benchmarking will be done. But mostly, I think the benchmark that has some human in the loop, so there's still a human factor, is the most stable benchmarking of the system. Because at the end of the day, if the results from the AI system are really good for human usage, then you've hit the jackpot. So those are the two pillars, and the last pillar it will be more from ethical point of view. So how biased is the system, especially in multilingual models? For example, with multilingual models, there was some use case that me and my colleagues were working lately. It was about a system that needed to handle documentation on multiple languages. So we had English, we had, I think, German, Chinese, and Korean. And for English and German, we didn't have any problem, mostly because LLMs have already a lot of data on that one. But for Chinese and Korean, there was some bias into the LLMs that we basically figured it out after we did some benchmarking on the AI system. So you'll see that those three, let's say, pillars of having the best practice framework for implementing AI systems are independent, but at the same time are needed. Like each of them is needed to have a fully stable AI system that can be used for, I don't know, for enterprise solution in the big tech companies, not just tech companies, in big companies in general.
Yeah, I'm really fascinated with some of the technical details that you drop, and I want to find out a little bit more about that. When you say benchmarking, what does that really mean? How does that work? How do you benchmark an LLM?
So how do you benchmark an LLM? So benchmarking currently is one of the biggest problems that the LLM have.
Okay.
As models. One of that is tokenization. That's another topic for another time. But the benchmarking can be basically approached from different routes. Probably you've seen when a new LLM dropped, like a couple of days when Claude 4 dropped from Anthropic.
Yeah.
How they do the benchmarking, there are already prepared benchmarking data sets from from most of the frontier labs or from research department institutes from the biggest universities in the world. And how the LLM is evaluated for a particular, we are giving a particular input, and we are seeing do we get the expected output for that system, or do we get anything else? And here we are extracting some metrics like BERT score, I don't know, Rouge, etc., etc. Pure mathematical statistical scores connected with classical NLP. and or accuracy, which is the most, let's say, intuitive metric for our humans. Like, how accuracy is basically how accurate is the system. If we have 100 entries and the LLM gave for 90 entries, the expected output is basically 90% accuracy. So something in those lines. And that's the manual evaluation of a system with already provided benchmarking datasets. Another really interesting topic which I explored during my master thesis was LLM as a judge. And that's really awesome because you're using another LLM to benchmark the outputs of LLM you, I don't know, fine-tuned or you pre-trained from scratch. And again, here you can already predict what will be the problem. What if the LLM we are using as a judge is biased, right?
Yeah.
So it's not a bulletproof solution, but it works. It works for most of the use cases. It's good for most of the use cases if you want to do an evaluation of a LLM fully the evaluation to be fully automated, to not have a human in the loop factor.
Yeah.
It's awesome.
Or you could envision maybe a scenario in which you have an LLM judge that flags when there's specific issues with the text, and then bring the human in the loop at that point. That's probably a case scenario that would work well in the linguistic scenario in which the text is machine translated. Some issues are flagged by your judge, as you called it. And then the human in the loop is a linguist who goes and verifies what is flagged by the judge. Is that kind of a real life scenario, you think?
That's the best case scenario that you can use for benchmarking LLMs, as you said. So you can automate the most of the system as LLM with LLM as a judge, and the LLM as a judge can flag the most problematic entries of the system or the dataset or whatever your usage it is. And a domain expert, in our case, a linguistic, can sit down and see the flagged ones to basically do the human evaluation of the problematic entries. Because I would assume that like most of the entries would be good, but I don't know, 10% or 5% of the created data set can be problematic. And in these cases, a domain expert linguistic can sit down and say, oh, this is why the LLM as a judge thought for this entry that is problematic, etc., etc. And it can evaluate it by so basically evaluation by combining the two biggest concepts.
Yeah.
Fully automated LLM as a judge and fully manual with human expert.
Yeah. So let's talk a little bit about how to make the research you're passionately involved in reality. Many AI labs are creating amazing texts or tech solutions, but enterprise adoption remains somewhat slower. What do you think is the key reason companies hesitate to implement the latest tools like synthetic data and these multimodal systems?
First of all, from what I've seen in the last 6 months, from talking with a lot of startups and a lot of enterprises, is the lack of understanding of how to integrate these AI tools, and basically to set up the framework we previously talked a couple of questions ago, to set up the infrastructure that is needed for developing AI solutions. That's the first moment. The second moment is I call this like resource constraint, more from limited budgets and technical expertise in their teams, which it is expected. For example, if you have a company that, I don't know, does a lot of medical stuff, medical research, or I don't know, plays with medical documentation, you would expect that the IT team or the team that is for allocated for the technical stuff would not have enough technical expertise to do this new AI fancy stuff, to do AI implementation tools. So those two one, and the third one is the risk management and the risk aversion. So still, especially in sensitive industries like healthcare and life sciences, you can see that most of those companies are really scared of implementing AI solutions from the perspective of safety, privacy concerns, etc., etc. But all of them, if I'm being asked, are solvable with a lot of work and a lot of resources spent. So if multiple AI experts sit down with those guys and say, "Oh, you want to implement AI tools? We have the expertise, we have the potential, we have the knowledge. Everything can be safely and securely implemented. Sit down, let's see what and where you can use AI tools." It's really easily, the implementation would be really much more easily compared to now. Also, what I've also seen is that like a lot of companies come to us, for in particular in Loca, and say, "Oh guys, we want AI, but we do not know where we will use the AI in our use case, but we want AI." And when we sit down with them, we say, "Oh, so what is your biggest problem?" And at that point, when they pinpoint the biggest problem, we know how to utilize the AI. Maybe not every solution needs to have AI incorporated, right?
Yeah.
So it's a double-edged sword. You need to think about, you need to set up the correct framework. You need to work a lot of with clients, but at the end of the day, I think what we are going to see in near future will be a lot of more, let's say, companies implementing AI. But the first step is to have a stable ground, stable pillars, the ones that we've talked.
Yeah. And maybe work the problem backwards, like you just said, figure out where there's problems within an organization that maybe could be solved by implementing AI. Speaking of that particular topic, maybe you have a couple of examples that you can give where AI was implemented very successfully and that kind of showcase the things that we've talked about this morning.
Yeah, in fact, couple of them. So like lately there were a lot of use cases of big documentation.
Yeah.
This is about a law company, organization that works with big documentations. And when I'm saying big, it's like one document has 100 pages, 200 pages, with a lot of details where each of the word means something. And those are really heavy to sit down and read them, right? If you are human, it's a really painful process. So what we did as a solution is we embed them, we store them into a vector database, something that you've talked on your previous podcast with Philip, using embedding models, and we were using the LLM to basically query them and to provide a summarization where we capture the whole information, but instead of reading the whole document, you're basically searching to the document, and the LLM will provide you a summarization in 1 sentence, 2 sentences, however you want, detailed or not with a lot of details. And you will basically have it like instant answer instead of looking through the documents for, I don't know, hours or minutes. That's one use case. Another use case, which is really also popular in the healthcare industry, is about transcripts. So in a lot of big hospitals, especially in ER units or emergency units, a patient will come up, he will tell his problem, you need to diagnose it and like everything, but you cannot write the document in real time about his problems, right? And
Right.
if you record the transcript with a classical voice recorder or a phone or a computer, you can have a system that transcript instantly converts into a text, and that text is instantly converted into structurized document. a document where like the patient's name is, the diagnosis, everything that came from the conversation, and you have that document instantly digitalized. Instead of spending like hours of writing that down by hand, you have it in the matter of seconds. So imagine what kind of automatizations can be done by day-to-day use cases. Or a third one, which is also interesting, something we tackled previously. Imagine you have access to multiple databases with a lot of finance data, right? And you need to basically do some insights of I don't know how many sales you will have this year, how to improve your marketing strategy, etc., etc. And you can say to the LLM, hey, we have these databases, you can use the data from here, give me a correct marketing solution, or give me a correct sales strategy to increase my sales by 10%. And it will do it. It will do it. So imagine like the solutions are endless for multiple use cases.
Yeah, it's fascinating. Um, what about the future? What can you tell us about your vision of the future in AI? What are the emerging technologies and what do you foresee impacting maybe localization and the multilingual industry a little bit? Do you have any advice or thoughts on that?
Um, I think from what we've seen, especially the latest models that are coming up, as like the Gemma models from Google, or the Quen models from Alibaba, we can see that most of them are now trained on multiple languages.
Yeah.
150 plus languages, 200 plus languages. So that means that good LLMs, good language models will be capable for us basic humans like me and you to use it by day-to-day basis without any fancy servers or infrastructure. So we can use it locally on the phone or on our laptops without paying a lot of money to the big providers, to the big LLM providers. That's one trend I'm seeing. The second trend would be let's say autonomous solution, or autonomous solving of tasks. So the agentic route. So we will see a lot of agentic implementation with multiple languages. Currently, the agents are a big trend with English. So everything that is based on English, it kind of works. But I see that those implementations can be also done with different languages: Macedonian, Serbo-Croatian, Chinese, Korean, or even small languages, and the multimodality. So having an omni model that can basically do any to any entry, so anything as an input, anything as an output, it will be a big one. So all of these processes are not fast. Nothing of this will happen tomorrow, but I think that humanity is going that route, and I think this would solve, in not now but in near future, a lot of problems that we have on daily basis as a humanity. But let's see. Interesting days are ahead of us.
Yeah.
A lot of new research, a lot of new discoveries ahead of us. And yeah, it's really fun to be part of this industry currently.
Yeah.
So let's see. Let's see what will happen.
Maybe one last question before we wrap it up. Working people want to know, and working people in localization want to know in particular what they can do to stay ahead of the curve and maybe prepare for this new tech space. What do you recommend people do to make sure they adjust with the times and are ready for the next developments in AI?
I think the most important one is, and this is more from human psychology perspective, to not be afraid. I see a lot of people that are afraid that AI will basically make to lose their job, or it will kill their profession. No, we are really early into the AI development phase. I want people, especially in the localization industry, to play around, to test LLM solutions, to not just LLM solutions, even classical AI ML solutions, to play, to experiment, to not be afraid. Now it's easy to even play around with big models. I mean, most of the LLM providers that have a good implementation of LLMs, like OpenAI, Anthropic, Meta Llamas, are easily hostable on their own cloud, or even on some of the models on a local machine. So download the models. For example, the open source meta models, the llamas, or the Quen models from Alibaba. Play around. Try to automate your stuff. Try to make your life much easier. I'm assured that you will not lose your job. And when you read about new AI research developments on the internet, take everything with grain of salt. So analyze it from not as an AI expert, more from human perspective experts. So as a human, these days you will see a lot of I don't know, on X Twitter, right, or on LinkedIn, a lot of AI influencers that say, "Oh, if you do not implement this large language model or AI system, you lose your job in, I don't know, 6 months." No, that's not true. So people, please play around, experiment with stuff. Try to find something, try to find an interesting use case for you that will help you on your daily basis. Localization folks, you will not lose your job. Even I think LLMs and AI in general will make your life much easier, and I think you will have much more ground to play around, and to do a better research these days, and to make let's say more information accessible to diverse population, compared to what we had in the background without AI, but previously without AI.
That's a positive note we can end on. Thank you so very much,
Yeah.
Bojan, for spending some time with us today. Fascinating interview. I can't wait to process it and share it with my audience. And we'll have to do it again sometime soon. Thank you very much, and have a wonderful afternoon in London.
Likewise. Thanks.